Well, we've been on quite a run lately, the last couple of weeks, tackling all sorts of rational functions. We started off just simplifying them, and then we tried to multiply them, then we tried to divide them, then we spent a couple of days adding and subtracting, and then we tackled some complex fractions, and we even finished by solving rational equations. And so today's kind of a day to take a deep breath and sort all this out and make sure that we can, understand them all at a very in-depth level. So our first goal today is we're going to try to describe and understand the difference between adding / subtracting rational expressions versus solving a rational equation. Now, sometimes instead of calling them a rational equation, sometimes we call them a fractional equation in our notes or on our homework. But the big difference is an expression doesn't have an equal sign versus, of course, an equation does have the equal sign. Our second big goal is to recognize and simplify complex fractions. And so we're going to work on some more of those again and just kind of compare them. And we're going to mix them all up tonight and see if we can recognize and identify and adjust as needed. So I just want to warm up with a little matching game here. We'll practice with some vocabulary. Over here on the left side, we've got 4 different topics that we've tackled recently. And over here on the right side, we've got 4 different types of problems. So we're just going to play a little matching game. So great time. Hit that pause button. See if you can match them all up. And it's just a real good chance to practice our vocabulary before we move forward. All right, so here's how I tackled these. I said, well, first of all, an expression means there's no equal sign. So I went, and of course we're looking for addition, so I went with this one right here. Let's see, multiplying, again, it's an expression, so there's no equal sign. So I'm going to jump on this one right here. Let's see, a complex fraction. Oh, okay, right up here we've got our minor fractions, like x over 12 or 4 over 3x, within the larger major fraction here we see. And then last but not least, the rational or fractional equation, however you want to call it, that's going to be the only one that's got the equal sign in it. And so when you solve that one, you'll actually have a number like x equals 5 or x equals 4 or something like that as a solution. Real quick review here with probably the topic that you feel the most comfortable with, multiplying or dividing rational expressions. Now, first things, if it is division, we're going to do something called keep, change, flip. We're going to keep the first fraction the way it is. We're going to change the operation to multiplication and flip that second one. And once we turn into multiplication, it's all about getting everything completely factored. And then once you factor, then we're going to just simplify or cancel as much as possible. And that's pretty much what it's all about. So it's about factoring and then simplifying everything that we can. So I'm going to go ahead and I'm going to try to kill 2 birds with one stone, if you'll let me here. I want to get everything factored as much as I can, and then I'm going to flip that second fraction over. So we've got multiplication now, and we're going to flip it. So I'm thinking x minus 4, x minus 2. Of course, they had to have the same signs because the 8 was positive right there. Now I'm looking for a GCF. I think I'm going to pull out a 3x cubed. And if I divide the first term by 3x cubed, I get an x, and if I divide the second term, I get a 3. All right. Now I'm flipping, and so I'm going to take a look at this rascal right here, and I'm going to get a. So if I pull out that x squared, let's see here. The first term will become 2x, and that second term will just become a 1. Make sure you got your 1 right there. And the top looks like a difference of 2 perfect squares. So the square root of 4x squared is 2x. And then I just need a plus 1 and a minus 1. And now we're going to go ahead and just cancel or simplify as much as we can. We could say, well, 2x minus 1 cancels or simplifies with 2x minus 1. Make sure you just, little thing here, but when you cross these out, make sure you cross off the entire binomial there. What else can we cancel? Ooh, I hope you saw this mistake quicker than I did. I think back up here, that 6 that I originally had, it should be a 2 right now. So let's make this a 2. We'll adjust on the fly here. And so let's go ahead, we'll cancel those rascals. I think I can cancel one more thing. I'm going to say the x squared knocks off 2 of the x's, but I still have an x left right there. So once the dust settles, what do we have left when everything else fades away here? Let's see, I've got the quantity x minus 4 on top, and it looks like I've got a 3 and an x, and the quantity 2x plus 1. And that's as much as I can cancel. This is my simplified answer. All right, now that we're working on adding and subtracting, I think this is one of the more challenging ones. It completely turns our world upside down. These are not anything alike with the multiplying and dividing, completely different. So the big thing here is I want to combine these two fractions into one fraction ASAP. All right, so let's go ahead and write that down. So I don't want you to ever lose sight of that goal. We are trying to combine these two fractions into one fraction. Now, in order to do that, we're going to have to create common denominators. And in the process of creating common denominators, we're going to multiply each fraction by 1, but it's going to be kind of in disguise. On the surface, it may not look like a 1, but it has the value of 1. So let's go ahead and jot that down as well. So emphasis just being on the fact that we are multiplying by a value of 1, therefore we're not really changing the value of either of the fractions, we're just changing how they look. Now the last thing I want to emphasize is the fact that there's absolutely no canceling on these problems, and that's what makes them so different than multiplying and dividing, until the very, very end after you've combined them into one fraction. Alright, so I think it's about time that we go ahead and try this rascal here. So, and again, I cannot determine what the LCD is until I first have it factored completely. So I'm going to go ahead, and it looks like the first denominator factors into x plus 8. And what's that going to be? X minus 4. So they had different signs. The 8 was the bigger one. And I'm going to change this operation to addition, and I'm going to distribute the negative through the second numerator. So I've got negative 4 I'm working with. And I've got a difference of two perfect squares, x plus 4, x minus 4. So I'm thinking that my LCD is going to be a combination of three different factors. The x plus 8, the x minus 4, and the x plus 4. So then the debate becomes, what do I multiply them by in order to create this common denominator? What I'm going to do is I'm going to multiply the first fraction by basically what it's missing, and that's the x plus 4. So I'm multiplying the top and the bottom by x plus 4. That's your value of 1. And the second fraction is missing the x plus 8. So I'm going to multiply the top and the bottom by x plus 8. Now here, when we're doing this type of a question on the Regents exam, the rubric explicitly says that if there is no attempt to create common denominators, it instantly becomes a score of 0, unfortunately. So we have to show this step, continue to focus on the process more than the final outcome as we go through here. So I'm going to make a note to myself that I'm going to have to FOIL these first two, and that's going to give me x squared plus, 4x plus 2x is going to give me 6x plus 8, and that's all over that common denominator of x plus 4, x plus 8, and x minus 4. All right. Now, up here I'm going to distribute the negative 4. It's going to give me negative 4x minus 32 all over that great common denominator we had. Remember, the order of those three factors is not very important. Whoops, that's a minus 4 there. This is be my x plus 8 here. All right, so now we're going to combine these two fractions into one fraction. I'm going to combine all of my like terms, and that's going to give me x squared plus 2x, minus, would that be 24? All right. Now, so here is, just when you think you're all done, we have successfully combined the two fractions into one fraction. This is the one time we get to allow ourselves to think about canceling. So I'm going to go ahead and I'm going to factor that numerator the best I can. And that's going to give me x plus 6, x minus 4. And we're going to see if that cancels with anything in the denominator here. And lo and behold, it looks like it will. We'll go ahead, we'll cancel those like quantities. And my final answer is going to be x plus 6 all over. And you could FOIL these out, but I generally don't. I just leave them in a factored form just like this. And this is my final answer. I've successfully combined two fractions into one fraction. Alright, now we're going to talk about complex fractions. I think they're pretty easy to identify. You've just got these minor fractions within the major fraction, and on this particular example, looks like we've got 3 minor fractions in the numerator, 2 minor fractions in the denominator. So what I'm going to do is I'm going to multiply by 1 again, and it's going to be the LCD over the LCD. And I'm just going to distribute that to each and every single term. So let's go ahead and we'll jot this down. We'll just say we're going to distribute the LCD to both the numerator and the denominator. So we're multiplying by 1, and it just happens to be in the form of LCD over LCD. As I look at this particular problem, it looks like if I consider all the minor fractions in their denominators, it looks like 12x is going to be my LCD. So I'm going to say 12x over 12x, and then what I'm going to do is I'm going to distribute it 3 times on top, and then I'm going to distribute it twice on the bottom. And it's going to look kind of crazy at first, but then I think it's going to make a lot more sense. Alright, so the first one as I distribute, it's going to be 12x over 1 times x over 12 plus 12x over 1 times 1 over 6. minus 12x over 1 times 2 over x. Okay, there's your numerator. And then on the denominator, we'll say 12x over 1 times x over 12 minus 12x over 1 times 4 over 3x. All right, here comes the fun part. We're going to start to cancel some pieces out. Let's see. If I look in that first group, I can say we're going to cancel the 12 with the 12. The product of the two remaining terms is going to be x squared. Then I got a plus sign, and then I look in the middle here. I'm going to say the 6 simplifies the 12, making it a 2. The product of what's left is 2x minus, and then I look right here, and I'm going to say, well, this x cancels that x, and we get a product of 24. All right here we're going to say 12 cancels the 12, we'll get x squared minus, all right, x kills the x, and 3 goes into 12 4 times. The product of the 4s is going to give me 16. All right, so we've got all the minor fractions cleared out. We're going to go ahead, we're going to try to factor the denominator, or numerator and denominator. I'm leaning towards x plus 6 and x minus 4. And difference of two perfect squares on the bottom. We're going to get those x minus 4s to cancel out. Bada bing, bada boom. We've got our final answer, ladies and gentlemen. It's going to be x plus 6 over x plus 4. And there's no more terms I can cancel. All right, so here's the big shift. Here's the big change that we need to practice. And now we're going to solve rational or fractional equations. Whichever term you like better, I can go with either one, whichever one you like better. And what we want to do is we want to clear the fractions. We want to try to eliminate those denominators. So if we want to clear the fractions, how are we going to go about that? Well, this is the first time where we don't actually multiply by 1. What we're multiplying by is the LCD. And the reason that's legal is because it's an equation, and whatever we do to one side, as long as we do it to the other, it's a legal move. So we're going to go ahead and we're going to distribute the LCD over 1 throughout the entire equation on both sides. Well, another classic example where we can't really decide what the LCD is until we get each of the denominators factored completely. Luckily, there was a plus sign in between those first two fractions, so that made life a little bit friendlier. And this is going to factor, I got to have the same signs, x minus 5, x minus 6, and they certainly add up to negative 11. What I'm going to do is I'm going to wrap up this fractional equation or this rational equation, and what I'm going to do is I'm going to identify my LCD. I'm going to say I need the quantity x minus 5 and I need the x minus 6. And what I'm going to do is I'm going to distribute that to all three terms, the first term, the second term, and the third term that's way on the other side. All right, so here again, this is where it gets a little bit crazy. And I'm going to try to fit it on my screen the best I can. And then the fun part happens where a lot of things cancel. Okay, so what you can see here in my setup, and I tried to, like I said, tried to squeeze it in the best I could, was I used the red pen to show my LCD here. And what I've done is I've distributed it to all three of the original terms, and the original terms are in green here. So you can see how I wrote it out real nice and neat next to each one, or as neat as I could here anyway. And now that, like I said, the fun part begins. We're going to start to cancel, and so here we are clearing the denominators, and the product of these two terms is going to require FOIL. So we got x squared, let's see, minus 6x plus 1x minus 5x if I combine them. And then I've got my plus sign, and then we're going to cancel there, and I'm going to distribute the 2. And then oh my gosh, look at all the canceling we got there. Everything cancels, so it just equals 2. Now we're sitting on a very typical quadratic formula. We're going to combine our like terms. That's going to give me minus 3x minus 16 equals 2. Now I'm going to set it equal to 0. I'm just trying to move all those terms over to one side. And then we keep our fingers crossed that it's factorable. And of course, if it doesn't factor, then we'll go with the quadratic formula. But luckily, I think we got lucky here. We're going to go with x minus 6 times the quantity x plus 3. Those two numbers add up to negative 3 and yet multiply to negative 18. And we're going to tee it up. And we're going to say x equals 6. We're going to say x equals negative 3. And then the question becomes, can I accept both of these answers? Or are we going to have to, whoops, that's a P. Can we accept these or are we going to have to reject them? Let's go back and look at the original denominators. And that will tell us our answer. So looks like right here, because of the x minus 6, with our domain restrictions, we would have said, and I'm going to go grab a different color here, we would have said that x is not allowed to equal 6 right there. And of course, x is not allowed to equal 5 either, but that wasn't one of our solutions. So because of this restriction right here, we're going to go down and we're going to reject the 6 as a solution. All right, and my final solution, make sure you do this on a test, is you use your solution set notation as a way of announcing what and who your final answer is. Well, probably our biggest challenge on a test is when we get two problems like we have here sitting side by side, and really we want to talk about and describe how we're going to attack them differently. And I want you to put these down side by side in your notebook, kind of split the page in half, so to speak, and let's be very specific how we describe how we're going to attack these. And I would definitely encourage you to try, start this one on your own. Just think about how you would attack them differently. So the thing that I caught my attention was the one on the left is a rational expression, whereas the one on the right is a rational equation. So the difference is basically, do we want to keep the denominators or do we want to clear them out? So the big announcement I made here on the left is that I'm keeping my denominators, but the one on the right, I'm going to clear them out. Keep versus clear. Keep versus clear. And all you got to do is just look for that equal sign right there. That equal sign tells you what we want to clear them, and when you don't see the equal sign, we want to keep them. Basically, on the left here, we're going to combine these two fractions into one as soon as possible, whereas the one on the right, we're going to distribute the LCD and clear out these fractions. So let's go take a look at this. So again, I really think you guys have got the hang of this by now. So again, a great opportunity to try this one all on your own. We're going to go ahead and we're going to pull out a GCF of 5. And let's see, and then we're going to, factors into, I'm thinking x minus 8 times the x plus 5. And now we just got to decide what we want to multiply by. My LCD is going to be a combination of 3 things. We're going to use a 5 right here, we're going to use the x plus 5, and we're going to use the x minus 8. Now what's that first fraction missing? It looks like he's missing an x minus 8. So we're going to multiply the top and the bottom by x minus 8, therefore multiplying by a quantity of 1. The second fraction is just missing a 5, very simply said. And I think we are ready to start multiplying. We're going to distribute. We get x squared minus 8x all over the LCD. Let's see, I put my 5 in parentheses. Could have put the 5 right out in front. Probably would have been a better move. Distribute the 5, we'll get 10x minus 15 all over 5 quantity x minus 8 times the quantity x plus 5. All right. So here's the exciting part. We're going to combine these two fractions into one fraction by combining all of our like terms. X squared plus 2x minus 15. Again, no canceling. Absolutely no canceling until after we've combined them into one fraction. All right, so let's think about it now. Can I factor, All right, can I factor the denominator at all? I'm leaning towards x plus 5, x minus 3. And when you stack that on top of the LCD, looks like we're going to get the x plus 5s to cancel. Boom, boom, wipe out the whole thing. My final answer is going to be x minus 3, and now I'm going to get smart and put the 5 in front all over x minus 8. And that, ladies and gentlemen, is our final answer. Our answer is a fraction, not a number. All right, our last one for tonight. We saw that the big difference here was that this one had the equal sign on it. So what I'm going to do is I'm just going to get that last denominator factored. I'm going to pull out the x so that it says x minus 7. And now we could say that our LCD is a combination of both the x and the x minus 7. That's my LCD. I'm putting it over 1, and I'm going to go ahead and I'm going to distribute it to both of the fractions on the left side as well as the fraction on the other side of the equal sign. And here's what it would look like once I get done distributing. Alright, so I distributed the LCD is in blue here, and I distributed that next to it. The orange terms represent the original terms that were in the initial equation, and so the fun part begins, and we cancel the x minus 7s, and as I do that, I'm going to distribute the x into the x minus 3, x squared minus 3x. Notice we have cleared out that denominator. Alright, here comes the trickiest part. We're going to cancel the x's, but what we've got to do is let's go ahead and make this a plus sign and negate the 1. So really what I've got to do is I've got to distribute a negative 1, thus making it negative x plus 7. And then we get over here, we're going to cancel the x's, we're going to cancel the quantity x minus 7, and the only thing we're left standing with is the 28. So now it gets a lot easier. It's a quadratic equation, so we're going to combine like terms, and that's going to be minus 4x. Meanwhile, I'm going to subtract the 28 over, and set it equal to 0. And I've got x minus 7 times the quantity x plus 3. We're going to tee this bear up. And then don't get too big in a hurry. We're going to say x equals 7, x equals negative 3. Can we accept both of these answers, or do we have to reject one? Well, remember, by looking at the original denominators here, we had domain restrictions. We said that x cannot equal 7. We said x cannot equal 0. So we're going to go down here. We're going to reject the 7. And our official answer is simply negative 3 by itself. Well, before we call it a night tonight, I want to throw out something really special that kind of went along with tonight's lesson. This is what I would consider an ultimate challenge. It is probably maybe a little too overwhelming, but I wanted to throw it out there and see if you felt brave enough to tackle it. What we have is a very, very, very complex fraction. In other words, we've got like a complex fraction within a larger complex fraction. So I wanted to just throw it out there, see if you want to solve it for extra credit. What we'll do is we'll make this worth 5 extra credit points on the next Wednesday quiz. And the only trick is you have to submit it separate from you can't do it. We're going to do it on a separate sheet of paper so that you can turn it in. And that's the big thing we're looking for here. So we're looking for 5 points on the next Wednesday quiz. And my hint to you would be to simplify the one complex fraction that's within the larger complex fraction. So we kind of have what's called a minor complex fraction and then a major complex fraction. So good luck. Hope you enjoy the challenge, and we'll see you tomorrow.